We will not set up a PLC for this system. The PLC is already connected, and the DIAP of course still has internet. So let's set up the PLC right now. I'll push add new PLC here. Then on the PLC type, I'll just select this 1200 from Siemens, which corresponds to the model we have. The protocol is S7, and the name of this one we can call demo PLC. The IP is 192, 168, and 11, and rack is 0, and slot is 1. I'll show you later on, maybe even in an overlay, how you locate these settings. Then location, that's more of a label, you could say. So where's this PLC located? Well, right now it's in the office, and the description of this is something similar to, you could say, a more descriptive label for this particular PLC. What's the purpose, for instance? But it's up to you. So for this, it's demonstration again. And here the scan rate is just, it's not specifically used for setting up the PLC, but it's used to carry over into when you set up the individual tags. So if I put 1000 here, then all following sensors or tags that I define under this PLC will have this value as a default value. So let's go with scan rate of 1000 and save changes. You'll see now how we have the demo PLC, and you can go in and see the settings again, but let's just leave that for now. I'll go in here, clicking on it, click add new tag. We can then select sensor type. Here it's just a demo wave, so we'll just select analog sensor with ampere, and we give it some kind of name. Here it's just going to be input 1, which is not really very creative, but that will do for now. And it's a demo wave, so we've just created a type here that corresponds to that. Data type is, let's see, it could be, there we go. It's a floating point number, 32 bits, according to that standard, and we have a whole range of different data types that corresponds to this particular PLC. So you have binary text, that's just digital ones and zeros. You have a date time, and some different floating points. Then you have some signed and unsigned bit values. You have just some text tags, and that's more or less it. But here we use this floating point number. Then we need to specify the data block that relates to the PLC, and the reason why it's here is that you can actually have several data blocks in the same PLC and then add them. So it makes sense to have it here. Let's put in 100 here, and the starting address is the starting address of this particular tag, and it's typically some number and then dot something, and in this case it's 14.0. So we just put in 14, and here you would put in if it was a digital binary value, but it's not relevant here. Then we have the scan rate, which came from the PLC. We'll still change that, but it's not really necessary at this time. Again, if you saw the video for the sensors, then you'll know that these two are the multiply and the offset are calibration coefficients. And I'm not going to go too much into the details about that, but leaving these here, then you will effectively just send the raw signal. If you want to scale it to, say you have a temperature sensor, if you have some other kind of sensor, then you might want to change these coefficients so you get the actual measurements. Anyway, we create this tag, and then these settings will be sent to the DIAP. But we are not quite finished yet, because there's one more step in this, and that's ensuring that we can actually speak with this PLC, that we are on the same network. So we need to be on the network, or at least have access to it via gateway. In this case, we don't have a gateway, so we'll specify an IP that's within this range. And let me just check here really quickly. If we go to DIAP and go into these settings, then we go to Ethernet, and we can just change this one. So we'll change it. We'll start by putting in 192 and then 168, and then switch this to 10, so then we're within the same range. And then we set this one to an arbitrary address. It's not too important which number it is, as long as it's not the same as the PLC. So recall that the PLC was 11, so we could put this to 10 or even 57 as it is now. So we'll just save that. So now you can see it's put here. It still hasn't sent that to the DIAP. We still need to push send save changes. Now in a little bit it will send these data to the DIAP, and we should be able to read this PLC. Alright, we'll go to add widget again, and we'll select line charts. We go into, this time it makes more sense to use a spline chart because of the way of a sinus wave. So we put in a retention period. We'll stick with 1 minute again, and I'll just browse through these settings. We select the PLC now, this time the DIAP PLC. Select the input. We can set some kind of limits here. It's not really necessary for this purpose, so we'll just leave it dynamic. And here we are. Here are the sine wave. Actually, it's a modified sine wave, but you get the picture. All right. That's it for the PLC. We'll just work a little with the different widgets next.